Silicon Low Pressure Sensors by Honeywell. Welcome to the training module on silicon low pressure sensors. This training module introduces how a silicon pressure sensor works, different types, and where they are used. In the 1950s, Honeywell's Corporate Technology Center completed basic research on the piezoresistive properties of silicon diffuse layers. The first Honeywell application of the piezoresistive device was a solid-state accelerometer for the avionics division. Pressure sensors have been produced for Honeywell's process control division since 1972 and have been applied over input pressures from less than 1 psig to nearly 10,000 psig. In 1972, Microswitch began to investigate piezoresistive device characteristics as a basis for further technology development. From 1972 to 1976, most of the Microswitch efforts was concentrated on working with automobile manufacturers because of the unique and time-sensitive opportunities that existed. This experience gave Honeywell Sensing and Control an excellent base for moving into other markets. Since 1977, Honeywell has actively pursued the general sales market. Piezoresistance of a semiconductor can be described as a change in resistance caused by an applied strain of the diaphragm. Thus, solid-state resistors can be used as pressure sensors, much like wire strain gauges, but with several important differences and advantages. The high sensitivity or gauge factor is perhaps 100 times that of wire strain gauges. Piezoresistors are implanted into a silicon medium, and the implanted resistors are integrated into the silicon forcing sensing member. Silicon is an ideal material for receiving the applied force. It is a perfect crystal and does not become permanently stretched. After being strained, it returns to the original shape. Silicon wafers are better than metal for pressure sensing diaphragms, and silicon has extremely good elasticity within its operating range. Silicon diaphragms normally fail only by rupturing. These pressure sensors offer state-of-the-art benefits of hybrid IC devices, including compactness, ruggedness, and reliability. Each Honeywell solid-state pressure sensor is developed around a square silicon chip with integral sensing diaphragm and 4 piezoresistors. Pressure applied on the diaphragm causes it to flex, changing the resistance, which results in a low-level output voltage proportional to pressure. The sensing resistors are connected as a 4-active element bridge for best linearity and sensitivity. Gold pads attached to the silicon chip surface provide connection to the piezoresistors and serve as pads for bonding of wire leads. The thin diaphragm is formed by chemically etching a square cavity into the surface opposite the piezoresistors. Sensing is accomplished by using a Wheatstone bridge configuration of resistors. Pressure causes the thin diaphragm to flex, inducing a stress or strain in the diaphragm and in the buried resistors. The resistor values change depending on the amount of strain they undergo, which depends on the amount of pressure applied to the diaphragm. Therefore, a change in pressure is converted to a change in resistance. All 4 resistors change by approximately the same value. Note that 2 resistors increase and 2 decrease depending on the orientation with respect to the pressure applied. The signal voltage generated by the bridge arrangement is proportional to the supply voltage and the pressure applied to generate the resistance change. Honeywell offers 3 pressure sensor measurement types: gauge, differential, and absolute. Gauge pressure is a form of differential pressure measurement in which ambient atmospheric pressure is used as the reference. In gauge devices, the P1 port is vented to ambient atmospheric pressure, which is approximately 14.7 psia, and the measured pressure is applied to port 2. An example is measurement of auto tire pressure, where a pressure above atmosphere is needed to maintain tire performance characteristics. Differential pressure is the difference between 2 pressures. An example is the measurement of pressure dropped across an orifice or venturi used to compute flow rate. In differential devices, pressure is applied to both ports. A change in differential between the top and bottom sides of the sensor leads to a proportional plus or minus change in voltage. Absolute pressure is measured with respect to a vacuum reference. In absolute devices, the P2 port is sealed with a vacuum representing a fixed reference of 0 atmospheres. The difference in pressure between the vacuum reference and the pressure applied at the P1 port causes the deflection of the diaphragm, producing the output voltage change. An example of absolute pressure is the measurement of barometer pressure. The Honeywell pressure portfolio includes the following product families: the SX and SCC series, the HPX series, the 24 and 26 PC series, the 20 PC SMT series, the SDX and ASDX series, the SCX and ASCX series, the CPX and XPX series, the CPC and XPC series, and the DUXL and DCXL SureSense series. Overall, Honeywell pressure sensors are small and low cost, which keeps system costs down. They feature excellent repeatability, high accuracy, and reliability under varying environmental conditions. In addition, they feature highly consistent operating characteristics from one sensor to the next and interchangeability without recalibration. Applicable industries include medical equipment, consumer products and appliances, computer business equipment, aerospace, industrial, and HVAC, as well as automotive. The SX and SCC series surface mount sensors provide a cost-effective method of measuring absolute and gauge pressures in a fully packaged sensor. The unique package design also allows a ported package option in a true surface mount sensor. They can measure both a positive and a negative pressure. Convenient pressure ranges are available to measure pressures from 0 psi to 100 psi and from 0 psi to 150 psi. The CC designation stands for a constant current source device. SX and SCC surface mount sensors are designed primarily for use with clean dry gases such as air, nitrogen, and similar gases. They offer a 4-pin closed bridge configuration for electrical connection with additional pins provided for mechanical support. The HPX series pressure sensors provide easy-to-use, miniature-sized, low-cost, and accurate sensing. The gauge devices are available in a 6-pin dual inline package or DIP, and the absolute devices are available in an 8-pin surface mount SOIC package. Both sensor styles are non-amplified and non-calibrated with pressure ranges up to 100 psi. The user can provide the HPX series sensors with amplification and signal conditioning circuitry to meet specific application requirements. These devices have a wide operating temperature range. The 24 PC and 26 PC series provides true wet-wet differential sensing capability. This means that a wet media can be applied to either the P1 or P2 port without damaging the sensor. This is accomplished by using a fluorosilicon seal to protect the exposed gold pads of the silicon die. All sensors in the 20 PC family are capable of multiple port configurations. The 24 PC series miniature pressure sensors provide reliable differential pressure sensing performance in a compact package. It is a low-power, non-amplified, non-compensated device capable of sensing from 0.5 psi through 250 psi. The 26 PC series has a factory-calibrated output and temperature compensation to provide reliable differential pressure sensing performance in the same compact package. The sensor features a proven sensing technology that utilizes a specialized piezoresistive micro-machine sensing element which allows part interchangeability, high performance, reliability, and accuracy. These low-power circuit designs provide an inherently stable millivolt output over 1 psi to 250 psi sensing ranges. The 20 PC series surface mount products are small, low-cost, high-value pressure sensing solutions for use with printed circuit boards or PCBs. Based on the long-established reliability and accuracy of the 26 PC pressure sensor, The 20PC SMT offers reduced size with true surface mount capability. The smaller size reduces the sensor's footprint on the PCB, thereby reducing the size of the PCB. The 20PC SMT is capable of being used with other SMT non-lead solder-ready components, helping to lower installation costs and eliminate secondary operations. Along with true wet-wet capability, other features of the SMT product are the unique pick and place pickup features on the port cover and the anchoring pins under the housing. These pins help to ensure the unit does not shear off the solder pads when the pressure hose is attached. The SDX family features an integrated circuit sensor element on a laser-trimmed thick film ceramic and housed in a compact solvent-resistant case. The package is a double-wide dual inline package with parallel ports to the PCB for low clearance. This extremely small size enables the use of multiple sensors in limited available space. The DIP provides excellent corrosion resistance and isolation from external package stress. The output of the bridge is ratiometric to the supply voltage and operates from any DC supply up to 20 volts with millivolts as the output per PSI. The SDX is capable of measuring both positive and negative pressure. The ASDX series is an amplified version of Honeywell's proven performer and industry-leading SDX series sensor. The amplified ASDX sensor's footprint is slightly larger than the SDX, but it offers a high-level output of 4 volts DC span on a cost-effective basis. This series is fully calibrated and temperature compensated with onboard application-specific integrated circuitry, also known as ASIC. These sensors are intended for use with non-corrosive, non-ionic working fluids such as air and dry gases. The ASDX DO for digital output device is in the standard DIP package and provides digital correction of sensor offset, sensitivity, temperature coefficients, and non-linearity. The SCX and ASCX series is similar to the SDX and ASDX. The SCX is a millivolt output device that measures both positive and negative pressure, and the ASCX series is a signal conditioned version of the SCX series. The amplified ASDX device is in the same package as the SCX, but offers a higher level use adjustable output on a cost-effective basis. The ASCX is fully calibrated and temperature compensated over a range of 0 to 70 degrees C. Both families measure absolute differential and gauge pressures from 1 psi to 150 psi. The low-pressure SCXL series is also available in the 0 to 4 inch and 0 to 10 inch water ranges. The SCX and ASCX series features an integrated circuit sensor element and a laser-trimmed thick film ceramic housed in a compact solvent-resistant case. It provides excellent corrosion resistance and isolation from external packaging stresses. The package has convenient metal mounting holes and large pressure ports for ease of use with standard plastic tubing for pressure connection. The CPX and XPX series sensors provide proven silicon micro-machine sensing technology in a complete family of low-cost packages. These entry-level sensors provide the most cost-effective solution for designs where external signal conditioning and compensation circuitry are available. Industry standard packaging includes a single inline radial or axial ported packages to provide superior replacement value in printed circuit board mount applications. These sensors are available in gauge, differential, and absolute pressure ranges. The XPX products are drop-in competitive replacements with pin-to-pin compatibility with Freescale's pressure sensors. The CPC and XPC series sensors are integrate silicon micro-machine sensing technology, temperature compensation, and calibration with the features and pressure ranges of the CPX and XPX series in a family of low-cost packages. These sensors are temperature compensated over 0 to 70 degrees C and are non-temperature dependent, which means no thermistor drift over temperature. This sensor series offers the most cost-effective solution for designs requiring sensor calibration as it eliminates the need for external compensation components in factory or field calibration. All ranges and performance levels are available in low-profile hybrid packages or imported configurations for use in PCB mount applications. The XPC products are also drop-in competitive replacements with pin-to-pin compatibility with Freescale's pressure sensors. These pressure sensors are designed to be used in a diversity of applications. They are ideal for applications requiring precise measurement of pressure, where the benefits of repeatability, low hysteresis, and long-term stability are important. In medical equipment, where accuracy is often critical, solid-state pressure sensors are used in airflow meters, kidney dialysis, handheld blood pressure monitors, oxygen concentrators, ventilators, and artificial hearts. The commercial market finds pressure sensors perfect for lie detectors, automatic bottle testing machinery, digital barometers, and automatic check sorters. Fast response is important in computer and business equipment. Pressure sensors are used in air bearings for tape transport for tape loop positioning. Honeywell pressure sensors are ideal for applications in the aerospace industry where high standards for accuracy are needed and extreme temperature ranges are inherent in the application. In industrial application, the broad sensing capabilities and ruggedness of these pressure sensors are well suited for use in pressure current transmitters, automatic plasma control systems, liquid level measurement, and automatic heating, ventilation, and air conditioning systems.